Okay, in one of the previous conversations, one of the videos I made, we covered example 3, which same section, x squared minus 9 equals 0. And I showed you how to do this from the difference of two squares. X squared is a square and 9 is a square. Difference means subtraction. So the difference of two squares, we were able to factor utilizing this type of formula. And I also told you couldn't find the sum of two squares. It could not be factored nicely. So I would like to go and cover a different method that we're going to be utilizing, but I wanted to show it to you before I went to the next one. We're now covering solving quadratics, the square root property. I'm going to show you how to do this using one we've already done before I get to the next one. To do the square root property, what you need to do is make sure that your x square is on one side and your constant square is on the other side of the equal sign. So we need to add 9 to both sides. And I get x squared is equal to 9. Now, the opposite of a square is a square root. All right. If I were to tell you to take the square root of 9, that is equal to 3. Period. Your calculator can do that. It will do it for you. But we know that 3 times 3 is 9. Here's the gig, though. Negative 3 times negative 3 is also 9. And you're not going to get that answer utilizing this. But because we're solving, we have an equal sign. This is the equation, and we're solving for x. When you take the square root of this side, that's great. But with the constant side, you need to put a plus or minus the square root of 9. Okay. Every time if you're solving for something, which means it's an equation, not an expression. So when you have the square root of x squared, that's just x, they cancel each other out, equals both positive and negative of the square root of 9, which is 3. So what this means is x equals positive 3 and x equals negative 3. You can write it like this or like this. Totally your call. I'm good with either one. I wanted to cover that before I jumped to the actual example that we start off with, because it's expecting you to be ready for my square roots. And if any of you have had 550 before this one, there's not a lot of square roots covered in there, if at all. So I wanted to get you comfortable with seeing how that works before we do this next one. Okay. Square root property. Example 6 is solving a simple quadratic equation using the square root property. We're going to use x squared equal to 8. They've already got the 8 on the other side. All we need to do is take the square root. So I'm going to rewrite this real quick. X squared is equal to 8. I'm going to take the square root of the left. That will give me an x. But on the other side of the equal sign, where the real number is, we have to do plus or minus the square root of 8. So we're going to get x is equal to plus or minus. Now I want to take that square root of 8 because I know there's a perfect square hidden in there. And I want the actual answer for this. So I want to factor this into the square root of 4 and the square root of 2. 4 times 2 is 8. The square root of 4 is 2. So 2 square root of 2. That is going to be our answer. X is equal to the positive of 2 square root of 2 and the negative of 2 square root of 2. No decimals. I expect to see it in square root version. All right. Solve a quadratic equation using the square root property. Okay, same concept. You need your x's on one side and your constants on the other. So they've got this kind of in a tricky situation, and don't be surprised if I do something like this on an exam. So I'm going to subtract 1 from both sides, and I get 4x squared is equal to 7 minus 1 is 6. All right. Now I want to divide both sides by 4, and I get x squared is equal to 6 over 4. Do not reduce this. Please do not reduce this, okay? Because when you take the square root, it's going to make it a lot easier if you don't reduce it first, especially in this situation. So when I go to take the square root of this side, the square root of x squared is going to give me an x, right? But on the right side, I have to have plus or minus the square root. So it's plus or minus the square root of 6 over the square root of 4. That's what I can do with this whole square root, is break it down to the square root of the numerator divided by the square root of the denominator. Earlier in, gosh, I think it was the last lecture, I told you no square roots in the denominator. So in order to, well, we're going to make sure that happens here. X is equal to plus or minus the square root of 6, because it's not a perfect square, but 4 is. So the square root of 4 is 2. My answers are the positive version of the square root of 6 over 2 and the negative version of square root of 6 over 2. All right. This next one looks a little hairy, and I know it can be very overwhelming, but it's truly the same concept that we're going to do with this one. I'm going to get you started, and then I want you to kind of take over just to get you going. 3x minus 4 squared equals 15. If you want to attempt this on your own, go for it. If not, let's see how I'm doing it. First thing I'm going to do is I'm going to get rid of this 3, because I can't have a square and a 3. That's not going to work on this side. I need to divide both sides by 3. These reduced. 15 divided by 3 is 5. Okay. Now that I've got a square on one side, my constant on the other, I can take the square root of this side. Don't forget your plus or minus for the constant side. All right. So the square root and the square cancel out. You get x minus 4. And for this one, you get plus or minus the square root of 5. It is not a perfect square. You must leave it in square root of 5 format. No decimals. So our answer here, we're not done. We have to add 4 to both sides of this equal sign. So this is going to be plus 4 here and plus 4 here. So I'm going to bring this up here. X equals 4 plus or minus the square root of 5, which is the same thing as 4 plus the square root of 5 and 4 minus the square root of 5. Again, I don't need you to combine them. I don't want the decimals. I would rather see it like this or like this. Either one, just make sure no decimals. Okay. All right. The next one is, we've got x squared plus 6x plus 9. All right, let's just break this down. Oh, we're just simplifying. We're not even solving for anything. We're not solving for anything because there's no equal sign. So this is just an expression. All right. 9 is just going to be 3 and 3, or 9 and 1. And we know that 3 and 3 is going to give us 6. Everything's positive here. So this is a perfect square trinomial. And what that means is, because we have 2 of the exact same binomial, this is the same thing as x plus 3 squared. Now there's a little trick for finding the square of a binomial as well. Let me see what this next one looks like. We've got x and x, 25. Well, 25 and 1 is not going to do it, so it's got to be 5 and 5. All right, this one was all positive, so everything was positive. This one, if the only negative is with the middle term, that means both terms are negative. You can check your OI, check your outer times your inner. Your outer is negative 5x and your inner is negative 5x, and they're going to add up to negative 10x. Okay, so this is the same thing as x minus 5 squared. All right. What is this next one they're wanting us to do here? All right, let me look to see what they want us to do here. Give me just a moment. So I was telling you there's a shortcut for binomial squared. I didn't mean coming out of it from here to here. What I mean is, if you have a binomial and squared, if you square the first, multiply the 2 terms together, 3x, double it, 6x, and square the last term, you'll get your trinomial for that binomial squared. Okay. The other thing they're wanting me to show you is, this is the beginning of completing the square, which we haven't started yet. And what this is, to find your third term to make this a perfect square trinomial, you're going to have to take your middle term, divide it by 2, and square it. And this is for any of them. If you're wanting to make a perfect trinomial, perfect square trinomial, you take the middle term, divide it by 2, and square it. 4 divided by 2 is 2. 2 squared is 4. All right, we have one last one down here. I don't see what's so exciting about this. I'm going to bring this 1 over here to the other side. X squared plus 4x. Oh, no, they're wanting us to actually, oh, I see what they're doing. They're wanting us to use completing the square. All right, so we'll go ahead and finish this one out before I go to the next one. So because I add 4 to this side, I didn't want to explain it this way. All right, we want this left side to be a perfect square trinomial. So we had to take 4 divided by 2 and square it, and we got 4. But because there's this cute little equal sign here, we need to add 4 to this side as well. Okay, now we can create a perfect binomial squared on one side, square root of the first. We're going to take the sine of the middle and the square root of the last. That's the trick for taking the trinomial squared. Or you could break it down into two parentheses and do what I did up here. Okay. We just need to add these here. -1 plus 4 is 3. All right, let's go ahead and do the square portion. Let's take the square root of both sides, plus or minus on the right. We get x plus 2 is equal to plus or minus the square root of 3. And we need to subtract 2 from both sides. X is equal to -2 plus or minus the square root of 3. All right, see you in the next video. Let me know if you have any questions.